The interior angles of a polygon are the angles on the inside, and the exterior angles are the supplementary angles connected to that angle on the inside. So these are basically the areas on the outside. We'll talk about these in a second. So first, interior angles. How do we find the measure of the interior angles of a regular polygon? That's the thing that we're typically concerned about. Say we have a regular n-gon and we want to know what the angle measure is. All right, so we can find the angle measure of a regular n-gon using a formula. So the angle measure of a regular n-gon is going to be equal to n, which is the number of sides, minus 2 times 180 divided by the number of sides. So, as an example, we have this regular, let's see, 1, 2, 3, 4, 5, 6, 7, 8, this regular octagon here. And if we want to confirm that the measure of the interior angles of octagons are indeed 135, we can use this formula. So we can say n is going to be 8 because we're dealing with an octagon. So 8 minus 2 times 180 divided by 8. So 8 minus 2, that's 6. So we have 6 times 180 divided by 8. And we can do 6 times 180 is 1,080. So 1,080 divided by 8. And if we do 1,080 divided by 8, we happen to get 135 degrees. So this tells us, this confirms that the measure of each of the 8 interior angles of a regular octagon is 135 degrees. So they all measure the same 135 degrees. The exterior angles of a polygon are the angles that are formed outside of the polygon. So for example, if we know the measure of an interior angle, we can find the measure of the corresponding exterior angle by using something called the linear pair postulate. And the linear pair postulate is something that deals with these things called linear pairs. What is a linear pair? Well, we hear the word line in it, and we've already talked earlier about how a line is a straight angle that measures 180 degrees. So we have something called a linear pair, and a linear pair is two adjacent angles. So this is two angles that share a common vertex and they share a common side that come together to form a straight angle. All right, so if I take this angle A and this angle B and I add the measures of these two angles together, the sum will be 180 degrees, and we see that it forms a straight line. This is called a linear pair. The linear pair postulate basically says that the measure of angle A plus the measure of angle B will be equal to 180 degrees if we have a linear pair. So again, if we have two angles that combine to form a straight line, then the sum of those two angles equals to 180 degrees. So if we look at this purple pentagon here, it's not a regular pentagon. So the previous formula that we just talked about how to calculate interior angles, we cannot use that because this is not a regular pentagon. But since we're given the exterior angles for this pentagon, we can find the interior angles using this linear pair postulate. So for example, starting with this angle, this is an exterior angle for the pentagon. And the exterior angle here is 102 degrees. But we see that it forms a linear pair. So if we can imagine this white line is not a part of the pentagon, but if we can imagine it extending out, giving us our 102-degree angle, this is a linear pair. So we have an angle here and we have an angle here. And based on our linear pair postulate, we know that the linear pair has to add up to 180 degrees. So if we're saying that 102 plus something equals 180, all we have to do to find this interior angle is subtract the value of our exterior angle from 180. So we do 180 minus 102, and we find that this exterior angle is 78 degrees. We can find this exterior angle the same way because, again, we have a linear pair. This 24-degree angle is a linear pair with this interior angle. So if we do 180 minus 24, we get that this interior angle, which is obviously obtuse, measures 156 degrees. All right. Likewise, we see here, this is actually a right angle. So because this is a right angle, we know that this angle is also a right angle because 90 plus 90 will give us that 180 degrees. All right. So this angle, this interior angle is 90 degrees. And here we have a 63 degree exterior angle. So if we subtract 63 from 180, we get that this interior angle is 117 degrees. And finally, we have an 81 degree angle. And so if we subtract 81 from 180, we get that our final interior angle measures 99 degrees. All right. So these are the exterior angles, and we can use the linear pair postulate to calculate the interior angles here because we can't use our formula because this is not a regular polygon. Okay, so one last example. So let's say we want to know what is the measure of the exterior angle of a regular heptagon. So since we have a regular heptagon, we can use our formula that tells us, and our formula tells us that the angle measure of a regular n-gon is going to be equal to n, which in this case, if we have a heptagon, it's 7. So that's 7 minus 2 times 180 divided by 7. All right, so 7 minus 2 is 5. 5 times 180 over 7. And so basically we're doing 5/7 of 180. And if we do that, what we get is 128 and 4/7 of a degree. All right, so this is the measure of each interior angle of a regular heptagon. So it's not shown here, but each angle here measures the same 128 and 4/7 of a degree. Then to find the measure of each exterior angle, all we have to do is subtract that measure of an interior angle from 180. So we do 180 minus 128 and 4/7 of a degree. And if we calculate the numbers there, we get that the exterior angles of a regular heptagon are all equal to 51 and 3/7 of a degree. All right, and so that is each of the exterior angles. So not just the one I've drawn here, but each exterior angle of this regular heptagon is going to be equal to that 51 and 3/7 of a degree. So if you can imagine, again, we can construct some lines going out here. And so each of these would be that 51 and 3/7 of a degree. The double hash mark here means that these angles are all equal to each other, but they are different than the interior angles, which each have a single dash.